In this video, I'll be teaching you guys about multiple statements in a quantifier. If you don't know what a quantifier is, I talked about that last video in my discrete math playlist. If you want to look at that playlist, link will be down in the description. And if you want to watch the introduction to quantifiers video, link will be down in the playlist as well. Which is not if you want to. If you don't understand what a quantifier is, oh, you best watch that. You best watch that because you're going to be completely lost in this video. But I'm going to teach you guys how to interpret what this statement looks like, right, in sentence form, and how to create statements like this from sentence form. So let's go ahead and interpret this. We'll take a look at the domain, and the domain for X is all students. Now this is very important, right? And I talked about that importance in the quantifier video, but yes, the domain is incredibly important. So we understand that the domain is all students, and we have X here, and X means, and we have X, what am I saying? X is all students in these statements. So X studies hard is the statement X, or the predicate X, and H of X is X does their homework, which is the predicate H. Okay, so we have this statement right here, and we have every X. So we already know this starts with for all or every, because that's what this quantifier means. So for all X, right, or for all students, since X is all students, so for all students we have studies hard, does their homework. And we have the and logical operator here. So we can probably construct a sentence that goes along the lines of, for all students, they study hard and do their homework. Okay? So for all students, they study hard and do their homework. Now that's probably a better way to construct the sentence. That, by the way, is probably like every student studies hard and does their homework. Okay, you know what? I should have wrote that. But every student studies hard, does their homework. That's basically along the lines of this quantifier, this quantified statement. So we have the for all. We take each part of it. So we have for all X, right, or every X. And in the case, we have domain is every single student. So we have every student, which is the X, which is domain of X after the quantifier. So every student studies hard, right, and does their homework. There it is. So basically these are kind of constructed similarly to the propositions, combining propositional statements together. But you have to be careful with some amount of interpretation with these, because it can get a little tricky sometimes, and I'll actually show you. Let's take a look at this quantified statement right here. This type of domain is all people, so we need to be a little more careful when we're constructing our sentence. But we have there exists a person, basically, right? Since the domain for X is all people, and this stands for there exists. Let's start off the sentence with there exists a person who is a teacher. So we have teacher here, and teaches math. Okay, I just gave you the answer there. There exists a person who is a teacher. Maybe it's maybe I should write whom. I don't know how to use whom or who. I learned about that when I was writing my college apps like a year ago. But you know what? This is not an English video. What am I even talking about? There exists a person who is a teacher and teaches math. So these statements are pretty simple to interpret, right? Going from the quantified statement, or whatever this is called, this entire thing, into a sentence. It's not that bad, right? There exists a person who is a teacher and teaches math. Now again, you have to watch out for your wording. I think you'll probably get a little, some of them get tricky. Some of them get tricky, and on the exams you'll probably get something like that. But basically what I did here was look at the quantifier. This quantifier stands for there exists. I look at the domain. The domain is all people. So we say there exists a person, right, which is this section here, who is a teacher, right, and teaches math. It's pretty step by step. This time, I want you guys to do the reverse of what I've been doing. I want you to create the sentence, to create the quantified statement from the sentence. So I want to go backwards. So before I turned the quantified statement into a sentence, I interpreted it for you guys in English. But this time I want you guys to do it backwards. You try it out yourself. try it out with the operators that you know, and come back to the video. So what do we have here? We have the domain. It's all decorations, right? We have all decorations at the domain, and we need to keep this pretty hard in mind. And the reason why is because if the domain was all snowmen, then there would be no point of the statement, right? No matter what, X will be a snowman, right? If the domain was all snowmen, then X will always be a snowman. So there'd be no need for the statement. That's why the domain is pretty important. But that's besides the point. I just want to specify the importance of the domain. But we have every here. So we already know we're using this quantifier, and we only have a single variable, X. Later on, you guys will deal with more variables, but let's not talk about that for now. We have every X, okay? That's usually the beginning of the statement when you say every. And we have snowman. So we have snowman has a carrot nose. Now keep in mind, this kind of looks like a condition. Does this look like a condition? It kind of looks like a condition, right? Every snowman has a carrot nose. This is the condition. You're a snowman. And then the conclusion is has a carrot nose, right? So the statement right here is S of X dash C of X. It's not the AND operator. I used to think this too. But this is a condition, right? Every snowman has a carrot nose. The condition is the snowman, or the hypothesis, and the conclusion is has a carrot nose. Now, I mentioned that the statement every snowman has a carrot nose is a conditional, not the AND operator. And the reason why is, and I'll show you, if you write it down in sentence form, the reason why will be pretty gosh darn obvious. So we have the domain here. All decorations, correct? If we write this sentence down using the AND operator, we write down every decoration, right? Every decoration is this segment right here is a snowman. And this might already be pretty obvious to you, but these sentences are completely different, right? We're basically saying every decoration is a snowman and has a carrot nose. Now, take your time and take a look at both these statements and take a look at why they are completely different. Of course, pause the video because I'm going to keep talking. But this right here, every snowman has a carrot nose, is just a condition, right? You're basically saying if there's a snowman, then it has a carrot nose. That's the if-then sentence structure. But this right here, basically in order for this to be true, we need every decoration in the domain, which is the domain, to be every decoration to be a snowman, and so the snowman part has to be true, right? And the carrot nose has to be true. So basically saying all decorations, are a snowman and has a carrot nose, which is completely different than every snowman has a carrot nose, right? So the AND operator is fundamentally different than the conditional, and you need to watch out for this when you're writing down the quantified statements because of that very reason. The AND operator and the conditional, their sentence structures are completely different. Okay, and I highlight that with these two example sentences here. Let's take a look at the statement here, and quite literally, the only change I made from the previous statement was the there exists section. So try to write the quantified statement off of this sentence and come back to the video. Well, we already know the there exists operator, or quantifier, sorry, is this guy right here, the backwards E. And our only domain is X, so let's write down X. And I mentioned the only variable is X because you're going to probably deal with more variables in the future. Good luck with that. That's a lot harder to learn, honestly. My video for that would probably be like 25 minutes or something. But this right here is the there exists part, correct? And again, the domain is all decorations. So we need to specify that what we're talking about is a snowman with the SX predicate that has a carrot nose. So let's continue on the sentence. That has a carrot nose. Is this a conditional? Is it not? Well, it kind of looks like a conditional, right? It kind of looks like the snowman's condition and the carrot nose is the conclusion, right? But that's not necessarily the case. It's actually the AND operator. Yeah, I know. It's a little confusing. The previous one, I told you that the for all statement had a conditional, right? The for all quantifier had a conditional. But this one, I'm now telling you, this is the AND operator. Okay? Why is it the AND operator? Well, in all honesty, you don't have to even care about any snowman. Any snowman that doesn't have a carrot nose. All we're saying is that there exists a snowman that has a carrot nose. So we don't care about any other, right? Like if there's a snowman and it doesn't have a carrot nose. We don't care about that. We only care about the one case of the snowman that has a carrot nose. So with the AND operator, we're basically saying all decorations is the domain. And if we plug in the decoration into the snowman statement, hopefully this is true, right? And the carrot nose is true. And that's all we care about. True and true. There you go. This exists statement only needs one case of the statement being true for the entire thing to be true, correct? So we don't care about any other snowman that doesn't have a carrot nose. We just want to know that there is a single one. So the conditional statement doesn't matter. Now, hopefully this helps, but this right here is the truth table for the conditional statement, right? And the truth table for the conditional statement has a false only when the condition is true and the hypothesis is false. Now, here's the thing. This isn't a conditional. And the reason why it's not is because the conditional is true when the hypothesis or the condition is false. Now, in the case of this sentence, all we care about is that there is a snowman that has a carrot nose. And we don't want the quantified statement to be true when there isn't a snowman, right? So this right here is basically states false, true, right? So if this was S of X dash C of X, we're basically saying the snowman portion is false if we take a look at this truth value. And this is a complete hypothetical. I'm not saying that this is what it is, but I'm saying that if we had the case where the snowman was false and the carrot nose is true, then this quantifier statement would technically be true, right? This quantified statement would return a true value because there's one instance of there being a true, right? When there's not a snowman, but something has a carrot nose, a decoration has a carrot nose. And we don't want that. We want that there's just a snowman that has a carrot nose. And the conditional does not suit that sentence structure. The conditional only cares about, the conditional is only false when the statement is true and when the condition is true and that when the conclusion is false. Now, if the condition is false, it will always give you back a true. That's not what we want, right? We want a snowman, right? But in the case of this conditional, false and false, right, just give us back this right here. The snowman is false. So therefore, if something just has a carrot nose, well, this will still be true, right? It doesn't have to even be a snowman. And this right here is supposed to be a false. But in the case of this guy right here, false, false, I'm basically saying that there is not a snowman and it does not have a carrot nose. It's just a decoration. And this will still give me back a true value in the conditional. That's not what we want. We want a snowman that has a carrot nose. We don't care about all other decorations that aren't a snowman. So the AND operator suits this sentence significantly better, significantly more, and actually appropriately in comparison to the conditional. The conditional just makes no sense for this statement. We don't care about the decorations that aren't snowmans. But the conditional states that if it's not, decoration is not a snowman, then no matter what, you're going to get back true, which is not the case for the sentence. So hopefully that helped. The AND operator and the little conditional, those are completely different, okay? Let's take a look at this quantified statement. And this quantified statement shows inequalities this time, right? Or equalities, just functions with numbers this time. And that's what my introduction to quantifiers video, I used mostly numbers and functions or inequalities. This one is just like the previous one, so maybe you're in your comfort ground right now if you watched that previous one, that previous video of mine. But our domain for this is all real numbers, and this basically stands for x, the domain of x. Okay, just think of it as that. So we have this right here, and we're basically saying for all real numbers, or x, right? So for all real numbers, x is greater than 2, and x is, let's write down and instead of the operator, and x squared is greater than 4. All right, is this the case? It's not, clearly, right? If you thought so, I'm not mocking you, but you might have missed something a little bit. I wish you could see my facial expressions. I don't have a face cam because I'm very, very expressive with my face. I was winking there, and whenever I make like quote symbols for like with my hands, like I say quote, I have to say it out loud because you guys can't see it, but I'm actually doing the hand motion and I'm actually doing like the hand gestures while I'm talking. Maybe okay, that wasn't even a relevant detail. Let's go back to the problem. I don't care, Jitty. I don't care. Yes, I know you don't care, but the domain is all real numbers, and here's the thing: for all x is greater than 2, right? So for all real numbers, is all real numbers greater than 2? No, right? That's clearly not the case. All real numbers are not greater than 2. Okay, 0 is a real number; it's not greater than 2. So this quantified statement is false, right? There exists one value of false, so the entire thing is false. Now here's the thing: what if we wrote down a conditional instead? So for this case, it's for all x, or for all real numbers, if x is greater than 2, then x squared is greater than 4. Okay, is this the case? Well, yeah, it is, right? If your real number is greater than 2 and you square it, it better be greater than 4. So let's take a look at a real number, right? That's close to 2, right? Let's say 3, right? 3 is greater than 2. And if we square 3, is this greater than 4? Yeah, 9 is greater than 4. So if we look at the conditional, it gives us a completely different scenario. We don't care. We don't care when x is greater than 2. It will always be true. The conditional just states that if x is greater than 2, then x squared is greater than 4. Now remember this, the conditional doesn't give a fuck. It doesn't care. It doesn't care about any of the real numbers that don't meet the condition, right? If you don't meet the condition in a conditional, true, 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 false, false, true, false, false. If you don't meet the condition, which is these values right here, a, b, a dash b, if you don't meet the conditional, it will always give you back a true. We don't care about any of the other conditions in the for all statement, right? I mean, any other conditions that don't meet the condition, any of the values that don't meet the condition. We don't care about them. They'll always give you back a true. And the for all statement, we're just looking for trues, right? But the for all statement, we look for false values. If there's a single instance of a false, right, in this conditional, then the entire thing is false, okay? But here's the thing. There's not a single case of this. Can you think of a real number that's greater than 2, but isn't greater than x, but x squared isn't greater than 4? Right? Because that's the only case where this conditional is false, right? When the condition is true, B is the hypothesis. So when the condition is true and the conclusion. When the condition is true and the conclusion is false, then that's the only time when the conditional statement is false. And for all statements, we look for a single value false. If one guy is false, then the entire thing is false, right? Because our statement is for all. So is there that? No, there's not. Therefore, this entire thing is true, right? If you're greater than 2, you better be greater than 4 if you square. But that's really it for this video. Now, the reason why I didn't cover the OR operator is I think that with the practice that you had with propositions, I didn't really need to cover the OR operator. I mostly tried to differentiate the and the conditional in this video, and the reason why is because the and the conditional is very tricky. Okay, the OR operator you can probably get from worksheets in your class. Well, if you want that video, I guess, put it down in the comment section. I'd be very happy to make more videos off of requests. It's nice to learn new things too, but really, that's it for the video. If you have any questions, put it down in the comment section. If you found this video helpful, consider subscribing and liking the video. Thanks for watching.